Hey student, welcome. We're going to be learning AP Calculus. And today I just want to talk about where does calculus come from? Where does the idea of calculus come from? How could we maybe strategize how to do calculus? Yeah, okay, so let's get started. So the first question that the AP book asks is, how does change occur at an instant? So in pre-cal, you might remember talking about the average rate of change. So I've got 2 points here. I've got, looks like 0, 3, and 4, 6. Okay. And if I want to find the average rate of change between these 2 points, we can kind of think of it as the slope of a line between those 2 points. All right, so we could say let's call this function f of x. So f of 4 minus f of 0 all over 4 minus 0. Now we keep going, right? So 6 and 3 are those values, just to do the calculations, 4 minus 0. So we get 3 over 4. So the average rate of change between, let's say, time 0 and time 4 is 3 over 4. So maybe we're changing 3 over 4 meters per second, for example. So this should be reviewed. We have talked about this in pre-cal. But calculus asks, what happens at a moment? So we know this for a period of time, but what if we wanted to know what's happening specifically at, let's say, time t equals 2 or x equals 2. What's happening here? How fast are we changing? So, we could try to say, okay, I'm going to put 2 points there on 2. And if we use our formula, it would be f of 2 minus f of 2 over 2 minus 2. So 2 points in the same place, we should get a slope, right? Well, the problem is when we do this, we're going to get 0 over 0. So we can't do that. We can't just find the slope in the same way that we used to. So the idea is, what if instead of putting that orange point right there, what if we started out with it here, we had a line like this, and then we brought it closer. Our instantaneous rate of change would eventually be very close to the actual rate of change at that second. So it looks something like this. And we call this the instantaneous rate of change, or the derivative, or the slope of the tangent line. So that's what we're going to be talking about a lot in this class. How do we get there, though? Because we can't plug in 2. We can't plug in 2 exactly, because then we'll get 0 over 0. We use a concept called the limit. So in order for us to take a derivative, which is what we want to do here, we need the concept of a limit. And to discuss that more, I want to move down here to this question. Okay, so we're standing away from our house, let's say 1 mile or 1 kilometer away from our house. If every minute we travel half of the current distance that we are to our house, will we ever reach home? Okay, so the first minute, we're starting 1 kilometer away, and then we end up here. Let's draw a little person there. That's about halfway. The next minute will be halfway from there. And we'll continue. I don't need to draw so many people. But if we're always having the distance, will we ever reach our home? The answer is no, we actually won't, because that distance, there will always be some distance, right? If we're 1 foot away, we'll be half a foot. Then we'll be a quarter of a foot. Then we'll be an eighth, then a 16th, then a 32nd, then a 64th. We'll always have some fraction of distance to cover because we're never going the full distance that we are between us and our home. But we're basically going to be at our house, right? We're going to be so close to the front door that our nose is touching it. So this kind of brings up the idea of a limit. In this situation, I could ask you, will you be at your home? And the answer is no, But we understand that you really are, like you're going to be there. That's the value that you're getting really, really close to. That's the limit of your travel. It is your front door. So this is just a basic introduction of what is a limit, what is the idea of calculus, and just a foundation for us moving forward. I'll see you in the next video. Hope you have a great day.